Two, or 6-3. I'm recording for anybody that wants to look at it. But yes, I am. There's a lot of 6-hour track people that might watch it. Okay. Confidence interval. Save your conversations back there. Confidence interval for, what have we done confidence intervals for so far? Population mean. Today we're going to switch. Confidence intervals for population proportion. Population proportion is your percentage of your population of whatever you're looking at. It's P. Okay? The point estimate that we use from the sample, the point estimate of P from a sample is P hat. So P hat is like our X bar. X bar is the sample mean. P hat is the sample proportion, or the sample percentage. And how do you get a percentage? You take your number of successes from your sample divided by sample size. So N was sample size. And X is your number of successes. In other words, how many match what you were looking for. S successes? I have no idea. I guess I'll bet the E in there. Okay. What do you think Q hat would be then? The percentage of failures. So it is 1 minus P hat, and it is your percentage of failures. What?
That's the actual term for it.
Q hat?
Yeah.
Yes. Q hat and P hat. I'm not making that up. Okay, so the confidence interval by hand. So confidence interval for P by hand. This one's a little bit longer. Okay, first step. Okay, it's not the magic number of 30 on these ones. You have to make sure the sample size is big enough, and it's very much like our last section we had in the last chapter, where we have to check N times P hat has to be greater than or equal to 5, and so does N times Q hat also has to be greater than or equal to 5. If both of these happen, then the sampling distribution is normal, and we can move on. If either one of those is not bigger than 5, then you can't move on, you can't do it, you can't do the stats with it. You have to increase your sample size. Okay. So then, your second step is still to calculate max error. And the formula here is z-score for your confidence level multiplied by the square root of P hat times Q hat over the sample size. And that whole fraction is under the square root. And then the third step is to do your interval, where you take your point estimate, P hat, add and subtract your error. And that will create an interval for population proportion. Let's talk about that. Okay, one little thing here. If p hat is not known, use p hat equal to 0.5, because that will create the biggest possible error you can have. So if p hat is not known, use a p hat of 0.5. Okay, the program. Program name here, we're dealing with proportions. The program name is called one prop for one proportion, z int, z interval. So one proportion, z interval. Good? So we'll go through one example by hand and by program, and then I've got a minimum sample size formula for you too.
Do we all have this program?
Yeah, everybody has this program. The important stuff everybody has. That table part, not everybody has. I need my book. Oh, I have my book somewhere. Oh, here. No, here.
That's not my cousin's room.
Okay, we're going to go try it number 3. Back. Okay, sample 1. Construct a 98% confidence interval. That was mean on my part, just so you know. Construct a 98% confidence interval for the proportion of adults who think trains are the safest mode of transportation. And the data that they did a survey of 935 adults, and they found that 16% picked trains as the safest. Oh, I have to do that. Okay. Okay, when we have the test, the goal is to find out what you're finding the confidence interval for. We want to find the confidence interval for proportion. It doesn't say mean. Every problem we've done up to today has said find the confidence interval for the mean. Now it's proportion, so that tells you to go to this part of your note card where you should have it labeled confidence intervals for population proportion, and then follow those 3 steps I just gave you. So, what was the first of the 3 steps? Checking to see if the sample size, I didn't really say it, but what this is a check to see if the sample size is big enough. Check for normal. And it's that n times p hat and n times q hat both have to be greater than or equal to 5. Remember, p hat is the percentage of successes as a fraction or a decimal. So what is my p hat in this problem? It is 16%. I don't actually know how many successes there are right off the top here, but I know my sample size. But I already know what p hat is. They gave it to me directly. So p hat is 0.16. What does that make q hat? If I have 16% successes, what does that mean for my failures? 1 minus 0.16 is 0.84. 84% failures. Okay, so now we're going to do that first step. Let's call this the first step. And check to make sure that this sample size of 935 is big enough by doing n times p hat. What is my n in this problem? 935 is my n. 935 times 0.16, and then I'll go n times q hat. 935 times 0.84. What is 16% of 935? 149.6? And q hat? 85.4. Very good. Okay, are we okay to move on? They're both greater than 5. If one of those was less than 5, we'd say can't do, give me another problem. So far so good? Okay, second step is now to find big E. Big E, I'll write the formula down again because it's on my other paper. Z-score for your confidence level, square root P hat, Q hat over N. Do you know the Z-score for 98% confidence off the top of your head? No, I gave you that purposely so you remember how to calculate a Z-score. How do I get the Z-score for the middle 98%? Subtract from 1, that leaves. Divide by 2 to get it in each tail. Inv norm the 0.01, and then we'll use the positive one. So what is the inv norm of 0.01? Let's go 2 places out on our Z. Positive. So now I know the Z-score, now we can move on. So 2.33 square root P hat and Q hat we identified up here, the 0.16 times the 0.84 over sample size, which was 935. Now the calculator challenge. Can you get the calculator to calculate what we wrote down? And trust me, I've seen many people not be able to do that. Do this? Oh no, I changed my Z-score. What are we getting for an error?
Got that.
0.279. Okay. So almost 3%. Any questions on that? You want me to do it on the big screen or good? Ashley, good? Okay. All good? Okay, now I can write the interval. And the interval is P hat plus and minus the error. You always do plus and minus the error from your point estimate. So for us,